Probably most of you know me. Basically, as Phil has said, I've got a PhD in zoology, and I've been very interested in this issue of creation and evolution for a long time. And I am a creationist. I won't let you try and guess that. I am a creationist, and I believe the Bible to be true. So we're going to tackle this contentious issue. We call it bones of contention. The contentious issue of the human evolution, or did humans evolve from apes, or are we descended from ape-like ancestors? That's the question we're going to consider tonight. So we're going to look at really 5 different things. We're going to be introduced to the family of the hominids. In case you're wondering, you are a hominid, officially speaking. We're going to look at some of the methods that the scientists use to evaluate the fossil hominids, and also to evaluate living creatures, living apes, and to see what the relationship is between humans and apes. And we're going to spend a bit of time looking at some of the key fossil hominids. There's quite a lot of fossil hominids out there, lots of different fragments. I'm afraid the old joke about the bones that support evolution of man from apes could fill a good-sized coffin is no longer any good, because they've got a bit more now. They can probably fit in the good-sized coffin. You might need 2 coffins now, but they've got a lot more evidence. It's quite confusing, some of it, which is actually rather important. And we can look at some very new evidence that's actually only come out this year. Since I've been preparing some material on human evolution for quite a while, and I wrote a short paper on it for a creationist organisation back in the beginning of this year in January, and I made a prediction that as more work is done, it will become clearer which are apes and which are human. And shortly after that time, a couple of papers have been published which do just that, and we're going to look at that new information, new evidence that's come out just this year. And we're going to have a quick look at genetics, because there's been some new information on the genetics as well, which is quite important when we're considering this question of the origin of humanity. So let's meet the hominids. We're going to look at some fossils from various genus of the hominids, or it must be genii, I suppose, in plural. I didn't do Latin. Basically, a genus is a family. You have different species united under one genus. So Ardipithecus is a genus, and there are 2 or 3 species of fossil creatures which are very ape-like. Then we're going to look at the Australopithecus genus, and there are about 3 species recognized in that grouping. We're also going to look at genus Homo, which is us. We are Homo sapien. The modern humans are called Homo sapiens, wise men. Somewhat pretentious, don't you think? But there you go. At least 5 species, probably as many as 9, depending how you draw your lines and how you divide up your species. And that's actually one of the issues which you often come across in this kind of debate. Where do you decide one species is different from another? Are they the same species? Are they 2 different species? It's actually quite confusing. So really we're going to try and deconstruct, if you like, the evidence that's often presented to us, conclusively proving, we're told, that we evolved from apes. So let's just have a look at the family tree. Here we have some of the key players in the hominid family tree. We have the gorilla, we have chimpanzee, and we have human beings. And the evolutionists tell us we're all related in some sort of family tree, and we've got various linking fossils, transitional fossils, we're told, which tie it all together. Or is actually the reality more like this, where we have separate lines? In fact, you've got gorillas, you've got humans, you've got chimpanzees. And what evidence have we got to show to support that claim, which is the alternative claim? So let's have a look at how we actually analyse the fossils. There are lots of different ways that anthropologists or paleontologists look at the fossils. And when studying human fossils, there are a few key factors which are very important. One way of analysing the fossils is to look at the humero-femoral index. It's basically the ratio of the length of your thigh bone to your upper arm bone. They also look at brain size. The story goes that we started out with small-brained apes, and we've got to large-brained human beings. So we're going to look at some of that evidence very briefly. We're going to look at knuckle-walking, which is a feature of an ape. Apes knuckle walk. And we're going to think about brachiation. Brachiation is basically swinging from one hole to another with your arms, like a chimpanzee does. And we're going to have a quick look at the semicircular canal as well, because the semicircular canal is actually very important in trying to distinguish between apes and humans, because the semicircular canal is related to the way you move around, and apes actually move around in a different way from which people move around. So we're going to look at these 5 pieces of evidence let's have a look now at the humero-femoral index. Here we have a skeleton, and here is the femur, and here is the humerus. If you're human, your femur is longer than your humerus. If you're an ape, it's the other way round. So you can actually get data. This is what the paleontologists do. Here's an extract from a paper where they looked at the ratio of the femur to the humerus, plot it out in a graph, and these are the various creatures that are included on this graph. So you've got Homo, which is humans, you've got chimpanzees, two different types of chimpanzee, gorilla, and an orangutan, and various fossils. And here is the line which is the ratio of 1. In other words, the femur and the humerus are the same length, so you get a ratio of 1. And above the line you have the apes, and below the line you have humans. And in the middle here you actually have some fossil creatures, as well as... No, I don't think you have anything else besides fossils. You only have fossil creatures actually on the line. So it looks like, from all the evidence we have, that if you're an ape, or if you're a fossil ape, it might be a bit contentious, that claim, but I'm claiming that fossil apes as well have an index between 1 and 1.3. 1.3 is up here, this is 1, and about 0.7 is human. And here are the human beings with 0.7. And in here actually is a fossil human called Homo erectus. But we'll come on to that, we'll come back to that. Brain size. Basically you have a primate brain which can vary from, if we consider we're all primates, let's for the sake of argument consider ourselves all primates. I would actually argue that we're not primates, we're humans and there are primates. But let's follow, I'm going to take actually mostly the evolutionist reasoning and show you how it falls down. So I'm going to reason like an evolutionist and consider that we're all primates. So the primate brain volume goes from about 350 mil for a chimp to about 1,300 mil for a human being. And here's some recent data summarizing the current knowledge of brain volume. Here you have your chimpanzees and your gorillas, quite small brain size, going all the way up to actually about 650. Here you have a creature called Homo habilis, which is a bit like the gorilla in brain size. And up here you have various different Homo erectus fossils, where they have the skull, they can actually measure the brain volume. And there's quite a variety here. It's actually a very large variation, which in fact to me suggests that they're mixing up more than one species together. Because if you look at human beings, your variation is much smaller, the same with chimpanzees and gorillas. So if you take modern creatures and look at the brain size, they're pretty consistent. You take the fossils, you've got a massive spread, which is unusual. And these creatures here in the middle are very recently described this year in Nature. They have an article about them, which actually confused the picture somewhat for the evolutionist. So here we have a story goes that from chimpanzees, or from apes rather, with small brains, you gradually evolve towards a creature which has a large brain, and that becomes human. But we're going to look at some of those assumptions a bit later on. Let's just explain what we mean by knuckle-walking. Now, if somebody tells you great apes are quadrupeds, you have every right to correct them, because great apes are not quadrupeds. They do not walk around on 4 legs. If anything, they walk around on 4 arms, because apes actually have 4 hands. Because you see them climbing a tree, you can see they've got hands on where their feet are. But they walk in a quadruped-like fashion. And here's a picture of a gorilla. I believe it's carrying a baby gorilla up here with this lump on the back. And it's walking around on its feet and on its knuckles. And the wrist bones are actually diagnostic. You can actually look at the wrist bones of an ape, you can look at the wrist bones of a fossil, they can take the fossil wrist bones, and you can work out whether they were knuckle walkers or not by the way they're constructed. They've actually got specialized scaphoid and radius bones. The radius bone is basically a large bone in your forearm, and the scaphoid is the first bone that connects your forearm to your hand, part of your wrist. And here the arrow is where the scaphoid is. And here's a diagram of a chimpanzee knuckle walking. And what happens actually during knuckle walking is the wrist locks into place. Our wrists don't lock into place, they flop around. You can pretend to be an ape and pretend to knuckle walk, but you're not, because your wrist does not lock into place in the right position. And this is actually designed to lock into place, just like our knees are designed to lock into place. And that is knuckle walking. If you're just walking around on 4 limbs without having a wrist that locks into place, you do not qualify as a knuckle walker.